Hi all, I am K. Surya, working as Assistant Professor in the Department of ECE at SNS College of Technology. So let us see a video lecture series on Signals and Systems Introduction. So in this video, let us see about continuous time signals. So first going into continuous time signal, we need to know what is a signal. A signal is nothing but a fundamental quantity which represents some information. In electrical engineering, the fundamental quantity that represents the information is, say, it can be an analog signal or a digital signal. So, analog signals are commonly known as continuous time signals. A signal that could be an analog quantity, which means that it is defined with respect to time. It is a continuous time signal. These signals are defined over continuous independent variables. They are difficult to analyze as they carry a huge number of values. A best example for, say, continuous time signal is our human voice, which is an analog signal. When you speak, the voice that is produced travel through air in the form of pressure waves and thus belongs to a mathematical function having independent variables of space and time and a value corresponding to air pressure. There are many signals in this world which change with respect to time and space. Some of the standard test signals are the signals which are used to estimate the performance and characteristics of the system by analyzing the responses of these signals. These signals are applied one by one as input to the system to determine different responses of the system in different cases, and then we estimate the different characteristics of the system, such as, say, stability, linearity, transient response, and frequency response by analyzing different responses, or we can say outputs of the system. So, standard continuous time signals which we are going to see in this video are unit step signal, exponential signal, sinusoidal signal, impulse signal, and ramp signal. So let us see one by one in detail. So first one is a unit impulse signal. So this is a signal which is denoted by del of t. So it has a value 1 only at the time period t is equal to 0. When t is not equal to 0, then the value will be 0, which is represented in the diagram in the left side. Some of the applications of this impulse signals are, it is used in system analysis. So we can obtain the impulse response which characterizes the system's behavior. It is widely used to analyze the behavior of linear time invariant systems. It is also used in control system design, signal processing, and in communication systems for channel characterization and modulation schemes. So one important property here is integration of minus infinity to infinity del of t dt is equal to u of t, where u of t is the unit step signal. So we can obtain del of t from differentiation of u of t with respect to time, which is given by del of t is equal to du of t by dt. Next one is unit step signal. So unit step function is denoted by u of t. So it is defined by u of t is equal to 1 for t greater than or equal to 0. So for all the values of t greater than or equal to 0, the value of the signal will be 1, and for t less than 0, the value will be 0 as shown here. So a step signal is one of the standard test signal. It is also known as Heaviside function or Heaviside step signal. So the magnitude of the step signal is a constant. So it exists only for the positive values and 0 for negative values. So it is used to analyze the system response to sudden changes in the reference input. So it is defined by its magnitude. Some of the advantages here is it is simple to generate the system response to sudden changes. Then stability analysis, it's versatile and it has applications in control systems, signal processing, electronics, motion control, and robotics. Next one is unit ramp signal, which is denoted by R of t. So it is an increasing function which increases linearly with time. A ramp signal exists only for positive values and it is zero for negative values. Ramp signal is used to analyze system response to linearly changing inputs. It is also known as velocity type input. Ramp input is defined by its slope. Uh, So for it is defined by R of t is equal to t for t greater than or equal to 0 and it is 0 for t less than 0. So it is a linearly increasing function as shown in the figure. Okay, so next one is exponential function. Uh, so exponential function is nothing but defined by x of t is equal to e power at. So the shape of the exponential signal is defined by the value a. So for consider, there are three cases here. The first case, if a is equal to 0, then your x of t will become e power 0, which is equal to 1. So it will be a constant value throughout. So if you have some value for a, which is a positive value, then it will be a exponentially decreasing function as shown in the figure. Third case is if a is greater than 0, then it will be e power at. So slope is called a rising exponential. Next one is sinusoidal signal. So it is of the form x of t is equal to a cos omega naught plus or minus 5 or a sin omega naught plus or minus 5. So as shown, it can be a sine wave or a cos wave where t naught is equal to 2 pi by omega naught. Some of the applications of fundamental continuous time signals are it's used in signal processing, communication, science, control systems, and in engineering. So let us take up some assessment questions. The step function u of t is integral of dash with respect to time. So it is a integral of impulse function. So u of t is equal to integral of del of t dt. Which of the following represents a continuous time unit step signal? The answer is u of t is equal to 1 for t greater than or equal to 0 and it is equal to 0 for t less than 0. What does the continuous time exponential signal e per at represent when a is a positive real number? So it represents an increasing exponential value. Thank you for watching this video.